Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms in general and how to do genetic algorithms, or how to perform processes and that involve genetic algorithms, and how to efficiently do them, and blah 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 blah. So yes, I must admit that this was a very bad opening in this video, but I have an excuse. It's not an excuse. It's not exactly an excuse. It's a lame one. So towards the end of my very last video, I signed out saying that I hope to record again in about a week or so, and that was 2025 July 8th. So let's just, I'm gonna do this. Maybe I want to pad for time, but I don't know what I'm doing. I just wanted to talk about what I've been doing since this date, and right now the date time is 2025 August 29th. So yeah, a lot of time has passed, and during this time I haven't done any video log recordings, so everything just seems kind of strange or new. So that's the end of my excuse, so I had to go back to what I said last time, retracing my train of thought, and trying to see if what I have been doing for the past how many days? This is 14, 18, no, wait, what? No, 24, oh, let's just say 23, and then 29, so 50 something days, 51, 52 days. So what have I been doing for the 52 days, for the last 52 days? And I'm trying to retrace that, and I just thought it'd be appropriate for me to record myself while I do that. So there were a lot of challenges. Everything was quite challenging, very challenging. Well, mainly because, not mainly, one of the biggest reasons, one of the major challenges was that I needed to make everything in a binary file format, in a Windows setting that would be an executable exe, but on Mac right now it's binary, it's bin binary file, and since I don't really know that well about the file structure the system structure, the system file structure, let's say, the architecture, whatever. That I don't know that much about it. I'm not an expert in that yet, and I hope I never have to be. But since when do I get what I want? So I'll have to be better in dealing with these formats. And that also reminds me that there were I have been thinking for the past 4 to 5 years that I may have to know how to do machine learning in C, or anything that is related to C, or on a something that is not Python, something that is faster and a lower level than Python. I know C is one of the high level languages, but since I'm comparing it to Python, yeah, I think that's fair. It's fair to say that. But right now, I have taken that the easy way out and just been using Noitka to compile everything that I wrote in Python into C, into an executable in C. And so yeah, and so far it has most of what I intended has been working, but I don't know when it will stop working. So that's something that I have to be worried about. Yeah, and the reason I made it into C using Noitka in a one file, I don't like red, in a one file manner. So every Python script would be compiled into C using Noitka in the one file mode. So everything is a standalone one file. And the reason I did that is that every entity now, for them to run in a parallel manner. How do you spell parallel? There we go. In a parallel manner, like I said. What is it? Yeah, multiprocessing and multi-threading and parallelism and concurrency, all of the good stuff. In a parallel manner, I needed to make every entity run in the form of a process that I could use, or that I could run rather, through the terminal, or a script, or a shell script. So that's what I have been doing, and that's why all of this took me 50 days to figure it out, and 50 plus days rather, and it was painful, excruciating, painful. It was like 40% fun, 60% pain, and 100% imposter syndrome. Imp sim. Yeah. And So where's the cursor? There we go. So what happens? What? Of course, I will have to make more videos that follow that explain how things are done right now, but the general idea is not so different. It's actually almost the same as how I designed it. I imagined and designed it. And I think that's why there were so many obstacles. I'm sure that there are so many other good tools that would allow me to do what I want, whether they be provided in Python by some Python libraries, or I could just straight up learn C and then do what I need to do. And there are some other tools, but I wanted to another excuse here for not doing most of what many people would suggest that I do is that I wanted to circumvent all of that in order to decrease the dependency. Not dependency strictly in the sense of library dependency or package dependency, but as I have said many times, I wanted to do all of this without using or relying on various external packages or libraries or modules. So I try to minimize the number of those. If there's something I need, and if it's pretty much straightforward, I would just code it in Python, albeit very crude and actually not that efficient. But I need the entities. I need these entities to be as not dependent as possible, and to do so I needed to circumvent all of the tools that other experts may have suggested that I use. So that's one of the excuses that I carry around and well, keep in my backpack or at the back of my head. So anyway, dependencies. How do you spell dependencies? I think that's it. Anyway, so and I also needed one more thing. I also needed to minimize the number of packages that I use in Python, because some packages may not be supported by where is it? By Noika here. So Noika has many packages that it does support, but I didn't want to depend on Noika for the support, because then if something breaks, it breaks. Everything breaks. So yeah. So minimize the reliance, the dependency, reliance, all the package dependencies. That's what I did. So far how it works is like this. There is the world executable, and then this kind of gives birth, let's say, to n number of entities, initial entities, which are void entities, as in their chromosomes are void, or their initial chromosome that they each have are all void. So they only have zeros. It's all filled with zeros. That looks like a Q. 0, 0, 0, 0, and on and on and on. That's how it goes. And these entities, each of them is a process. Of course, the world.bin is also a process, but these entities are also processes in the form of a binary file. And these will just start running. For example, 10 entities will just start existing. That's 5, 6, 7, 8, 9, 10. They'll start existing, and what each of these entities start doing is that the details I'll probably cover in the videos to come after this, but what each of them start doing is that, for example, this entity, as soon as it is started in the form of a process, it will choose whether it wants to mutate or learn or procreate. Now, when I say choose, I mean it is randomly selected. So that's all done in a while loop for now. And that's one loop. In one loop, one entity can either can choose to mutate, learn, or procreate. But I left out the chill option. Now, when an entity chills, it doesn't do anything. It just exists. That's hence the name of the function being chill and exist. Now, the reason I put this in is that in my last video, well, not the very last one, in the probably the second last or the third last video, I remember saying that it is actually beneficial for the entities. It is actually beneficial to not have all the entities do something. Make sense? It is it saves time. It saves time. It is computationally cheaper, and it just gives a nice sentiment as well. You know, it's okay to chill. So that's what happens, and that's one loop. So they can do one of these four things. You know, given their own probabilities, actually, because it's using the random choices function from the package from the random package. So the random package is one of the very few packages that I use. There was just no easy way of going around that, so not too bad. Okay, after a very long period of awkward silence, I'm back. So that's what this does, and each entity. So this entity will do that as soon as it started. This entity will do that. This entity will do that. This entity, all the n number of entities that has been initiated by the executable named world.bin will start doing one of these four things and per one loop. And while that's going on by all these entities, the world process will incorporate all the, or rather incorporate all the entities that are up and running, you know, at that point in time, and for each loop, the world entity, in the world executable, the world process, let's just write process here, is also a loop. I know it's bad to use while true, but it is also a loop. And this loop will continue until the blib reaches the maximum blib. Now I had to introduce one or two new ideas in order to implement this concept in this true chaos version of genetic algorithm, of the genetic algorithm. Yeah, so this goes on, and towards the end, at the end of every loop, this is one loop again, one loop, it will again evaluate all the existing entities, and well, when I say evaluate, it means to calculate the summed utility values of all the entities. So calculate the summed utility values of all the entities that are running, entity processes that are running, and also store that in lists to be saved after the while loop has been broken. That is when the blip reaches the maximum blip, and store all of the information in the final result dictionary to be saved into a JSON file. Okay. If I put, now that I actually, write it down like this, it actually looks very, very straightforward. Almost embarrassing for me to, almost embarrassing to me, for me and to me, that because of the fact that this took me 50 days, 52 days, around 50 days. Yeah. So that's about it. And right now, as I am wondering how I should make the future videos from now on, I am having trouble in finding the right entity event ratios. I'll cover this in future videos, but getting the right entity event ratios is actually very, very tricky because of the way these entities behave. Oh yeah, it's really bad. Not that bad, but it's really bad. So, one thing that I think I should just clarify in this video is that one more thing is that should the entity choose to procreate, it will give birth to another set of entities. Just right now, just one entity gives birth to just one single entity. So this comes from here, and maybe this comes from here. Okay, or rather, I said that the other way around. This entity gives birth to this one. This entity gives birth to this one, and these new entities, in this case, these new entities, 3 in number, because 3 of them gave birth, will be included in the world. Along with the already existing entities right here. And when they do get included, these are the new ones, newborns, each of them will also get to choose to either mutate, learn, procreate, or just chill. And again, this goes on. Should this entity choose to procreate, it will give birth and initiate another process, a new process that is an entity that would just do one of these 4 things again. So in a way, this is like not in a way, I should say this is a chain reaction. It does look like a chain reaction, and and if I do it wrong, the number of entities or processes just explodes, and the computer will just come to a halt, just stop. So I've had to forcefully end processes so many times, whilst being scared that whilst being scared that I might brick my laptop. But yeah, and then this is when I realized that what I'm doing right now is one of the few tactics that malware creators use to overload a machine, a device. So I had to be very careful, and I still have to be careful. And turns out running a lot of processes just takes up a lot of your computing power. Duh, I should have known that. But that's how this way of doing things, this way of doing true chaos genetic algorithm is different from the pseudo chaos, or even before that, comparing it to dynamic genetic algorithm. But I believe that this is a very necessary phase, a step that I have to go through. Yeah, and it's challenging, it's very hard, but it's fun, it's very rewarding. Yeah, so very challenging to learn how to optimize. I think that's a very nice way of putting it. Optimizing is super duper hard. Or it might not be hard, but it's hard for me right now because I don't know what I'm doing. I'd love to say I know what I'm doing, but I don't think I do. So, being humble, being wary, but I guess that's how I need to view things. Yeah, it is a chain reaction. Because, well, where is it? Come on, I want to draw something. I want to draw. Okay, I'll just have to zoom in. It is a chain reaction because that's so bad. Give me green. I will have entities. For example, 5 initial entities. N equals 5. And then if some entity chooses to procreate, for example in this case only one entity, this will choose to do something in the next loop for every, and as soon as this starts, this is the first loop of the initial entities, and then something gives birth, and all of these other entities that did not choose to procreate would have done something, including just chilling and existing. But and after having done that, they'll keep running because it's all in a while true loop. It's in an infinite loop. until the entity either gets struck out or limited. So in the second, in their second loops, in the loop following that, some of these entities could choose to procreate as well, and this entity was lucky enough to procreate again. So this is the third loop. And then in the next loop, even after that, this entity chooses to procreate, and this entity chooses to procreate, and so does this, and so does this. Did I get that right? Yeah, actually I did. And so does this, and so does this. So starting from 5 entities that are still running, now we have 5, 8, 10, 15 entities. And then if 4 of them choose to procreate, that's a bad one. And some others, 4 of the new ones choose to procreate, and maybe 5 of the already existing ones procreate. Three, 4, and 5. Now we have something close to 30. Is it 30 though? I don't know. I lost count. And this is by the 4th loop. I mean, for example, for this entity, this would be by the 3rd loop, supposing that every entity process runs almost at the same time, almost at the same speed. Velocity, speed, I don't know. Yeah, supposing that happens. So by the 4th loop, starting from the initial entity's point of view, it's already 30 entities, and we started from 5. And after that, it will grow to something like 50, and then 100, and then suddenly 160, and then suddenly 300, and that's how it goes. So this is why it's so computationally expensive, and maybe that is one of its biggest downsides. Actually, one of the most fatal one, actually. Yeah. So lots of challenges to come when controlling how many entities are newly introduced, even after having some entities struck out and limited. Yeah, so this is where most of the challenges lie. That's about it for this video. Okay, thanks for watching. See you next time. Probably in 3 or 4 days. I hope. I really hope. I really hope it doesn't take me another 52 days to make another video. Okay, bye.